everyone, I am Ayush Pandey and today we'll be starting first chapter of class 12, that is electrostatics. Okay, it is a quite vast chapter, so we'll be covering the things one by one. Okay, first we should know the meaning of the name of the chapter, that is electrostatic. Okay, here it means uh, charge at rest. Means in this chapter we will be talking about the phenomenons that happen when charge is kept at rest. Okay, charge isn't moving, it is not in accelerated motion, it is at rest. Okay, now the first terminology that comes here is electric charges. Okay, so we define electric charges as it is basically a property associated with matter. Okay, property associated with matter. Okay, due to which associated with matter, due to which it experiences it experiences or you can say produces and produces electric and magnetic effects. Okay, this is the basic definition of electric charge. Okay, and when body gets charged, uh, the deficiency of electron, okay, or the excess of electrons, okay, electron deficiency, okay, or electron excess. Okay, this is the reason why any body gets charged. Okay, when there is a deficiency of electron, the body gets positively charged, and when there is an excess of electron, body gets negatively charged. Now we will see the unit of electric charge. Okay, units, there are different units that we'll be using in this chapter. Coulomb, the first one is Faraday. Okay. Ampere into second. Okay, these will be the units which we'll be using in this chapter. Okay, now we convert 1 Faraday into Coulomb as 1 Faraday is equals to 96500. Okay, dimensional formula will be dimensional formula that will be 80. Okay, for electric charge. So these were the basic terms, basic information of the electric charge. Now we'll move to the properties of electric charge. Okay? The first property is that electric charge is a scalar quantity. Okay, scalar quantity. Okay, means the charges can be added. Okay, can be added without consideration of the direction. The second property, that is charge is transferable. Transferable. Okay, that means if a body is put in contact with another body, then the charge can be transferred from one body to other body. Okay, charge can be transferred means there will be a transfer of electrons. Okay, third one, associated with mass. Okay, okay, associated with mass. Okay, now this is a property, third property. Okay, now the fourth property is conserved. Means the charge is what? It is conserved. What does this mean? This means that for an isolated system, the charge, total charge on the body does not change, although distribution may change. Okay, for example, this is a body. Okay, isolated system. Okay, uh, there is a charge. Okay, like this. Suppose the net charge here is uh, minus 2 coulomb. Okay, so this distribution may change. Okay, but overall net charge on the isolated body, that will remain what? Minus 2 coulomb. Okay, this is what conserved means. The fifth point is fifth property, that is invariant. Okay, charge is what? It is invariant. Invariant means the charge, for example, if a body is here, okay, it is having plus 2 coulomb charge. Okay, and it is moving with some velocity, then the net charge on the body will be independent of the frame of the reference. Means whatever will be the speed of the body, okay, that is not going to affect the net charge on the body. Okay, means Q is independent of velocity of the body. Okay, that this means that charge is invariant. Invariant basically means independent of the frame of reference. Okay, so these were the some basic properties of the charge. Okay, I'm giving you one question. Tell me, a specific charge is variant or invariant? A specific charge. Okay, think, think, think for a second. A specific charge basically means Q by M. Okay, here mass is what? Here mass is coming, and we know mass is what? It is variant. So Q by M will be what? It will be variant. Okay. So these were the basic properties of the charge. Okay. Next thing we'll look comparison of charge and mass. Okay, charge and mass. The first comparison we can make is charge is what? It is invariant. Mass is what? It is variant. How can you say this is variant? We have seen this relation m is equals to m naught upon under root 1 minus v square by c square. Okay, here m naught is what? It is rest mass. Okay, and this is what? This is kinetic mass. So this from this formula you can already see, okay, that mass is what? If a body is moving with some velocity, then mass can be what? It can be varying. That means the mass depends on the velocity of a body. Whereas uh, for the charge, something like this doesn't exist for the charge. Okay. Now the second thing is one more point that I would like to add is suppose if there is a body, okay, it is having charge 2 coulomb, okay, then this body will possess some mass as well. Okay, but a body, suppose its mass 2 kilogram, doesn't it is not a type of requirement that this should also possess charge. Okay, means wait a second, means a body with charge, a body having charge cannot exist without mass, but a mass can exist without having charge. Okay, so this is a basically uh, one relation. Okay, now one more thing I would like to add in the properties, six properties, that is quantized. Charge is what? Quantized. Okay, quantized means the charge possessed by any body q, that will be integral multiple of electronic charge. Electronic charge is what? It is smallest charge, smallest charge. Okay, okay, every charge, any charge, all charges, there will be what? Integral multiple of electronic charge. Electronic charge is what? Basically 1.6 into 10 power minus 19. Okay. So these are the properties in comparison of mass and charge. Okay. Now methods of charging. Okay. See, there are different methods of charging. The first one is charging by friction. Okay. Okay. Charging by friction. Uh, what we does in this method, that if we rub one body with other, then electron gets transferred from the body to the other one. For example, this is a glass rod, okay, and this is a silk, okay. Then if we rub this body, then what we see, that electrons get transferred from this body to this. So the new configuration will be something like this. Okay, okay, like this. Okay, means charges got transferred from this body to other. Okay, this is basically charging by friction, and we call it what? As frictional electricity. Okay, okay. Now the second method is what? Charging by conduction. Okay. As you can see from the term conduction, it is basically the process of transfer of charge by contact of the two bodies. Okay, means with the contact of two bodies. Suppose if a body A and if they are connected, then electrons will get transferred from the bodies, and the flow of direction of electron will be you can all you know I think you didn't know that positive charge flows from higher potential to lower potential. Okay, so electron will flow from lower potential to higher potential. Okay, so electrons will flow from the body which is at lower potential to a body which is at higher potential until the potential of both the body will get same. Okay, so in this method the charge is transferred through conduction. Okay, this is the second one. Now the third is charging by induction. Okay, induction. Basically, charging by induction means charge is transferred. Okay, uh, charge is transferred without direct contact. Okay, without direct contact. Okay, what we do in charging by induction, we bring the charge body, okay, to a uncharged neutral body, okay, which is grounded to earth, something like this. Okay, then this body will get what? This body uh, gets charged. Means there will be a charging by induction. Okay, this is basically basic phenomenon. Okay, and now the charge bit gets transferred. Means the charge bit gets induced on the body. That is known as induced charge. Okay, induced charge. Okay, and that is the charge that appears on uncharged body. That is what induced charge. Okay, and induced charge is what? What is the one property that it is opposite to inducing charge. Okay, opposite to inducing charge. Okay, so these were the some methods of charging. Okay, so thank you.